Ever wondered why we can't just make it rain when the earth is parched and dry? Well, it's a question that has puzzled scientists and laymen alike for centuries. Rain, that life-giving force, can be as elusive as it is essential. In different corners of the globe, rain scarcity is a harsh reality that people grapple with daily. Imagine the arid landscapes of sub-Saharan Africa or the sun-baked expanses of Australia's outback. These regions experience the brunt of rain scarcity, and the effects are far-reaching. Agriculture suffers, parched fields can't yield crops, and farmers face grim prospects. Water supply dwindles, causing a ripple effect on the overall living conditions. Thirsty cities, barren fields, and dry riverbeds are all too common sights. But here's a thought to ponder, a question that might shift the paradigm of our understanding. What if there was a way to summon the rain at will? Interesting, isn't it? Scene script. Enter the fascinating world of cloud seeding. Imagine you could unlock the skies and let the rain pour down at your command. Sounds like a fantasy, doesn't it? Well, it's not quite as far-fetched as you might think. This is the concept of cloud seeding. At its core, cloud seeding is a technique designed to squeeze more moisture out of clouds. Picture it like this. Clouds are like sponges filled with water. Under normal circumstances, they'll only release that water when they're good and ready. But what if we could persuade them to give up their moisture a little earlier? That's where cloud seeding comes into play. It involves introducing substances into the clouds to stimulate the process of rain. These substances, often silver iodide or liquid propane, act as a sort of catalyst. They encourage the tiny droplets of water in the clouds to come together and form larger droplets. And when these droplets get big enough, gravity takes over, and they fall to the ground as rain. Now, you might be wondering, why bother with all this? Why not just let nature take its course? Well, the answer to that lies in the increasingly pressing problem of rain scarcity. In many parts of the world, rainfall is becoming less predictable and more erratic due to climate change. This poses a serious threat to agriculture, water supplies, and ultimately, our way of life. By using cloud seeding, we could potentially coax more rain out of the clouds and mitigate these effects. In theory, we could turn dry, parched lands into flourishing green landscapes. We could ensure that crops have enough water to grow and that reservoirs are filled to the brim. It's a tantalizing prospect, isn't it? So cloud seeding seems like a silver bullet, doesn't it? But let's delve deeper. It's not magic, it's science. Let's understand how cloud seeding actually works. To grasp the science behind cloud seeding, we first need to understand the natural process of rainfall. You see, for rain to occur, tiny water droplets in clouds need to combine and grow large enough to fall to the ground. This process is usually facilitated by the presence of ice particles in the cloud. These ice particles act as a nucleus around which water droplets can accumulate, forming a raindrop. Cloud seeding essentially aims to accelerate this process. It involves the introduction of certain substances into the clouds, substances that are known to encourage the formation of ice particles. These include silver iodide, potassium iodide, and even liquid propane. Picture silver iodide, for instance. Its crystalline structure is remarkably similar to that of ice, making it an excellent ice nucleus. When silver iodide particles are released into a cloud, the supercooled water droplets, that's water below freezing point but still in liquid form, latch onto them. They freeze, forming ice particles. These newly formed ice particles then act as nuclei for other water droplets to condense upon, growing in size until they're heavy enough to fall as rain. The delivery of these seeding agents into the clouds is often achieved with the help of aircrafts or ground-based generators. Aircrafts can fly directly into the cloud, releasing the seeding agents, while ground-based generators release the agents into the air where they're carried upward by wind currents to the cloud. Liquid propane, on the other hand, works a bit differently. When released into the cloud, it expands and cools rapidly, cooling the surrounding air. This rapid cooling can cause supercooled water droplets in the cloud to freeze into ice particles, thus kick-starting the formation of raindrops. So you see, cloud seeding isn't about creating water out of thin air. It's about enhancing the natural process of rain formation, making it more efficient, more predictable. It's about turning the seemingly impossible into a reality, one cloud at a time. Clearly, cloud seeding is a scientific marvel, but where in the world is it already in use? And cloud seeding isn't a futuristic concept. It's happening right here, right now. Countries all over the globe are already tapping into this technology to alleviate water shortage and combat drought. Take China, for example. They're planning to cover an area larger than India with artificial rain by 2030. The United Arab Emirates, a region known for its arid climate, has been using cloud seeding to boost their water supply for years. Over in the United States, states like California and Texas employ this method to fight against severe droughts. Australia, too, has been experimenting with cloud seeding to replenish their dwindling water reserves. These examples only scratch the surface of the widespread use of this fascinating technology. It's clear that cloud seeding is more than just a scientific marvel. It's a practical tool that's helping nations around the world tackle real-world problems. The world is already harnessing the power of cloud seeding, but is it all rainbows and sunshine? Like any scientific advancement, cloud seeding too has its share of debates. On one hand, it holds the promise of alleviating water scarcity and drought conditions. On the other, it raises a flurry of questions about the potential unintended consequences. Critics argue that cloud seeding could unintentionally alter weather patterns, potentially causing floods in one area while depriving another of much-needed rainfall. This could disrupt ecosystems, affecting wildlife and plant life alike. Beyond the environmental impact, there are ethical considerations as well. Who gets to decide when and where to seed clouds? How do we ensure equitable distribution of rain, particularly in regions shared by multiple countries? These questions underscore the need for rigorous scientific research and robust regulatory frameworks. As we grapple with the realities of climate change, these debates will only intensify. As we continue to battle changing climate patterns, could cloud seeding be our secret weapon? Or is it a Pandora's box we're yet to fully understand?